Okay, so let's look at it. So we made it 3 separate problems. Fine. Linear thing right here. So 3 natural log of absolute value of that divided by the derivative of the stuff inside. Alex, what's the derivative of the stuff inside? 1, so I don't need to write it. Here, whose derivative is positive sine, or negative cosine? So the integral is negative cosine of stuff divided by the derivative of stuff. And Jamie, what's the derivative of stuff in this case? 7. So you divide it by 7. E to the stuff is e to the stuff. So the integral of e to the stuff is e to the stuff divided by the derivative of stuff. He didn't divide by -5, or did he? Kara, what do you see?
Well, it was originally negative.
It was originally negative and now it became positive, and it should have. And then plus C. No numbers on any of those, so no evaluation. It could be off by a vertical shift. Ari, is there a question?
No, here.
Okay, you chose to sit where you did.
No.
You can move your desk.
No, this is fine.
Okay, so in each of these, maybe you wanted to use U substitution to make sure you didn't lose the constant and know how to deal with it. Did you have to? No. You could have just gone to this step. For this second one, do we need U substitution? Oh, yeah. And the things on the exit card, by the way, were all off of the homework. I did 6 different exit cards, and 2 of the questions on each exit card were exactly off the homework, and I chose the numbers for the other 2. Like, there's 2 different versions for each class. At least one of the questions was exactly off the homework, so that hopefully it wasn't crazy. This one, what would the U value be?
The U value would be ln x.
The U value would be ln x. Yep. What's the derivative? 1 over x dx. Can you do the translation for us so I can go find her text?
I got like LN. Oh, that's an 8. I think it's like a 6. Yeah. Oh, LN is just 1.
You're good.
Well, you said LN 0. LN is 1, right? Yeah. No, LN 0 isn't.
You're in the right.
Isn't that okay? Yeah, that's why I was confused. Why did I say that? It's because I thought, well, I figured they just leave both. I need to start reading wrong. Okay, this is 1. Well, I feel like LN 1 and LN 0, right? And since LN 1 is 0, so, you know.
Okay.
Oh.
So, translating, this becomes 1 over u, and x dx is du. When x is 8, u is natural log of 8. When x is e, that's a 1. So then integrating this, Jamie got natural log of absolute value of u evaluated from here to there. And that's natural log of 8 minus natural log of 1, which is 0. This does not evaluate, it's not natural log squared, it's just gross. Yeah, questions? And I just want to make sure that you guys understand physics applications of the calculus. I got text messages from my child in college yesterday. I was rather disappointed. I'm like, sweetheart, that's pre-cal. And if you want to do it with calculus, fine. Integrate gravity.
So we can, you see that the position is at -5.
So acceleration is 32. Velocity is the integral of acceleration. And to use notation from physics, they'll use v sub 0. Which actually, I should not do that because I didn't give you initial velocity. I gave velocity at 2 is 10. So the equation of velocity right now is and Nick, the integral of velocity gives us an equation for what? So the position is and it's telling you position at time 2 is -5.
And I'm gonna solve this by myself.
-39. -44, add the 44 to the other side. So there's an equation for position. And in pre-cal, we told you guys to use the equations -16t squared plus blah, 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 or -4.9t squared. Y is half of gravity. Power, raised power divided by the new power. Doing it twice, we divide by 2. Right? Okay. Were there any lingering questions from yesterday that we didn't cover because you guys were like stressed about the exit card?
On 41, there were two questions, like 39 and 41 or something at the end, like, no. I think like acceleration and velocity.
41?
Yes.
That one?
Mhm.
Yeah, okay. Is it that different from what we just did?
No.
So do we need to do it? I mean, it's quick. The integral of velocity or acceleration. Initial velocity there is 20, so plugging in t is 0. The initial velocity was 20. Integral of velocity is position. And our initial position was 0, so plugging in 0 for t and 0 for the position, we get that. Yeah.
Is acceleration always gonna be just like 32?
For projectile problems on Earth that didn't have another acceleration force like the power, yes, but they'll be more complicated.
Right.
Gravity on the moon really is different. All right. We need to do these boys. This is often, like, these are big questions on the AP exam. They're often on the free response. And one of these on its own is often 5 points. And if you look at the grading rubric, if they do not do step 1, 0 out of 5, no partial credit. So step 1 is really important. So write the problem down and then we're going to talk about what step 1 is. So step 1 says, well, it says solve by separation of variables. So maybe I need to make x's be with x's and y's be with y's. Does it make sense to put dy on the bottom? Or do the dy needs to stay up top and I want the dx up top? So my first step, I'm going to divide by the chunk that has y on it. So that's step 1, you got a point. And when it says solve the differential equation, they often will say in the form of y equals f of x. They want you to get a function. Okay, I'll do the hard part. Raise the power, divide by the new power.
Where did dy go? Is dy supposed to be?
dy is supposed to be here, sorry, thank you. Yep, thank you. Thank you, Ari. She's like having a heart attack over there, where's it going? You're right. How do I integrate the other side though?
Well, do.
What's the whispering? What do you guys see?
Is it use substitution?
Definitely use substitution, but you might recognize it differently. What do you see? I recommend rewriting it. Not doing any math at all, just maybe rewriting. What can be rewritten? That's what was this? Right as multiplication? Okay, that's not gonna change enough for us.
Secant squared root y over root y.
So Jasper, I thought you were doing like move it up top. Okay, that's a big hint. It's still hard, but that's a big hint. So it's u substitution, but what is the u value? Is it the thing being raised to the power? Is it the thing inside the trig function? Is it the thing under the square root? Is it the thing in the denominator? There's all kinds of sneaking choices. Root y? Why would it be that?
Integrating so you can square just tangent, so then it's easy if you just change it.
Okay, integrating secant squared is just tangent, so it's the junk inside that's the problem. So that's the thing that we might need to mask. Annie, what's the derivative of square root of y?
1 inverse.
Multiply by the power, lower the power, and then multiply by the derivative of the stuff inside. Yeah, okay. So Sophie, how do I swap things out?
Now that you can replace the thing in the denominator just with 1 because it's equal, or with 2 because it's equal to 1 over square root of y, and then in the top you can say secant because like of.
So she says dy over the square root of y is 2 du. And I wrote it as a fraction already, so I put a 1 under there because it was uncomfortable. This side's already integrated. And Luke already said the integral of secant squared is just tangent. And the u value is that, yes.
Would you keep a C or two? Would you have a C when you do the integral of secant squared?
Okay.
Or would it, like, when does it get?
All right. So, yep, this is when these conversations happen. So, you're right. Like, I integrated this side and I got plus unknown vertical shift. How come I didn't add an unknown vertical shift here? Well, I'm gonna sweep this unknown junk over there and unknown pile of stuff with another unknown pile of stuff. Can I still call it unknown pile of stuff? So I'm gonna only add it once, and I'm gonna say I swept everybody over to the same side. What?
When we're on the exam, do we have to like do like plus CS, CY and
No,
show our work?
No. Which is why I only left it as a plus C, but to show you, it didn't matter, I squished them together. Roxana?
Would it be like wrong to put it on both sides?
It would confuse you. Like, it makes the problem hard for you, so don't. It's not wrong, but don't. Josh?
If you don't notice, one over cosine squared is secant squared,
You're screwed.
because then it's like natural log and stuff.
It's not natural log, because natural log of something to the first, that's to the second. Like, it's not natural log, so it's, you have to see the
Oh, it's
cosine
one
squared is
over.
secant squared, and that I know secant squared's derivative of tangent.
Sorry. At the end, we have to,
We're still not done, but
okay.
okay, so as I said up here, usually they wanna give the equation as a y equals f of x. Do I have y by itself? Do I even have x back in there? Or okay, u was square root of y. 2 tangent square root of y equals x squared over 2 plus c. Do I have y by itself? No. Marthon, what do I need to do to get y by itself? Okay, and I'm gonna do math violation here, and I'm allowed. I still left it as plus c, I did not divide it by 2, oh my goodness. How do I do that?
Yes.
It's an unknown pile of stuff, so I have half of that pile of unknown. It's unknown. It's going to matter eventually, but not yet. Okay, Camden, how do I undo, I still don't have y by itself.
You have to do inverse too.
Oh, gross. So square root of y equals inverse tangent. And here's the thing that you guys are gonna do wrong. The c is in that arctan. It's the whole entire side. Yes, Amir?
Nothing.
Okay. So first thing in these guys, as soon as you do this integration, you need to add that plus c in there. If you think about it later and toss it in at the end, it's gonna be wrong. And that's another thing on the grading rubric for these things. 0 out of 5 if you do not separate the variables. And at most 2 out of 5 if you forget the constant. And then we get this weird equation that's completely bizarre. Arctan squared of grossness. Whew. Yay. Okay. Try separating the variables.
Derivative of y is, okay.
This is just.
Can anyone tell me how to separate them? ACOS?
Is it either x over either y? Yeah. Once we get it.
Yes?
Oh.
So Preston, I need y's with y's, x's with x's. What do I need to do? Is this like super easy to integrate, or am I missing something? What's the integral of e to this stuff? E to this stuff. So Lily, what do I get? Equals n plus c. Am I done? Yes, all right.
No, why is there no plus c after we did a y? Because you still took the.
Can anyone answer that, Hadley?
Because it's unknown and even though you realize you don't need to add it twice.
Really? So e to the y plus something, e to the x plus something. Don't know what the somethings are, so as I said, I can check the timeline on the recording. 6 minutes ago, sweep the unknown from this side all to the,
I know how to,
Oh,
okay. I know how to find y, simply do the natural log of both sides.
okay, great idea. Natural log of both sides. As here's, oh, Camden, yeah.
For the EY, EX, you don't have to divide by like
The derivative of the stuff, like, derivative of y with respect to y is 1. So you're right, and it was 1.
Are you able to find C now instead of
Okay.
doing it?
Good question, good point. All right, guys, right here, I'm gonna follow the track that someone else just suggested, but then we're gonna double back and answer another question. So to get y out of the exponent, we need to do natural log, and it's natural log of this entire side. So on the left, we just get y equals natural log of e to the x plus c. Can I evaluate that?
It's still C, it's just still C.
Okay, it's still stuff, but I wanted an actual answer. So now I'm gonna plug in the one coordinate they gave me. The y value is natural log of 2. And over here, e to the 0 plus c. What is e to the 0? 1. So natural log of 2 equals natural log of 1 plus c. What is the c value? 1. I can take the insides out and set them equal. So going back here where I plug things in, my final complete answer is that.
Yeah, it ends up being C.
It does. So that's one method, yeah.
If you, like, if the bases are equivalent and the exponents are different, can you note that you can just set the exponents equal to each other?
Don't generalize like that. There's a c in here that is not part of the exponent that's gonna mess you up. Okay, can I erase the red? Because there was a question of Well, I don't wanna do that. And the question was, can I plug the coordinate in here to get e to the y equals e to the x plus c? Over here, we get 2 equals 1 plus c, c equals 1, and then I need to go back here, put that 1 in there, and now do natural log of both sides, and I get y equals natural log of e to the x plus 1. Yes. So, if you noticed, up here, I put an asterisk, and that's when I plug things in. Got my c value, I need to go back to there and plug the c value in. When I went back and plugged it here, I needed to plug it into the pink stuff. So wherever you plug in your initial value, now your c is fixed. So at this point, c is no longer an unknown lump, it's a specific thing that I need to calculate. So if I multiply both sides by 2, I need to distribute the 2 to the c as soon as I plugged in. Hopefully, there's another example. Yep. What is happening? Yeah. Okay, hold on. First of all, these are not the same, so I want you to. Okay. What's stopping you is you've got the long rules backwards. Yes.
Oh. Because I did not get the same answer.
Okay, so you've got
Yeah, I
addition inside,
understand.
you're just stuck.
Okay.
I'm confused about how to get them.
I need to move y's with y's, x's with x, so what's the first step?
Oh, the ln x is.
Where are all the y's? So this guy needs to move.
Oh, no, I didn't.
How do I get him out of there?
4.
What is he, like, is he adding, subtracting, multiplying, or
And I
dividing?
changed.
So how do I do multiply?
To make it more.
Yeah, okay. So divide.
And we kept the 1 for it.
Is it fine if I divided by the 4 with y too?
Okay, so here's a suggestion on the separation of variables. Square root of y, just by itself over there, okay, move it. The number, you can keep the 4 where it is or move the 4 to the denominator in the left, it's your choice. I don't know which one is better, so if you feel it's beneficial to move it, go ahead. So there, you got 1 point, yay.
If the fourth, if it's, are you looking to move like a part of the constant over?
If you want to, but again, I don't see that as, okay, I know what you're wanting to do, but, sounds like more complications, but if you see that, sure. Like, why were you wanting to move something? What's the integral on the y side?
It's 1 over 2 root y dy.
Well, integrating this, what is the integral of 1 over root y? Raise the power from -1/2 to +1/2. And dividing by that new power, dividing by 1/2 is multiplying by 2. And then, all right, am I gonna add a plus c here, or can I hold it and just dump it on the other side? Okay. Okay, this one, done this a few times now. Hopefully, this is old hat. Integrating u du raise the power, divide by the new power, so u squared over 2. And I'm going to put the u value back in. And this is why Sydney was looking ahead and like, can I take part of that 4 to the other side? You can. I don't have y by itself yet, and I didn't solve for c. Sasha, what's your preference? What do you want to do?
Square both sides.
And when she says square both sides, that's everything, including that plus c. And if you add the c too late, it doesn't work right. Preston?
You need the double parentheses, right? Like if you don't have the parentheses around the ln x, it's not the same thing.
If I don't have the parentheses around natural log of x, that's natural log of x squared
Okay.
versus natural log of x times natural log of x. Okay, Tom?
Well, when you square everything, if C, because like you get
If c
ln
is
x
0,
special,
it's not going to change anything. But if
like,
c is,
since we don't know C, do we really have to square everything, or can we just square that?
well, the problem gives us the ability to solve for c, so yes, I need to. Sophie?
I know that you put the C on that side, but if you put it on the other side, wouldn't you like subtracted C and then would that have been wrong?
Okay, if you put the c on the side with the y's and you solved and you got c is 3, then it would be y plus 3 equals stuff, and I would have solved and I would have gotten a negative 3.
Yeah.
So it comes out as the same.
Okay.
Like, when plugged in, we will get the same y value in the end.
Okay.
All right, but I need to find c. Brooke, how do I find the value of c?
Let me just know. 1 for y and e for x.
What's the natural log of e? 1. 1 squared is 1, so 1 equals 1 plus c squared. What is c? 0. Oh, well then my answer here, so that's where we plugged in the values. Y equals natural log of x squared squared, which is natural log of x to the 4th. Yes.
There's 2 solutions, so that 1 equals 1 plus a squared. And be -2 also.
-2 also,
Even though we didn't like square there.
that's the -1. Yes, and do they both happen? I feel like that one's extraneous and I'm not finding the position where it, like, putting in a -2 here and an x value of e. Putting in the x value of e here, I get a 1 squared minus 2, which is a -1, and the square root was given to us as a positive in the first place, so it is extraneous, but that's really hard to see. So the -2 is not an option, and I didn't think it would be that hard. On these are these are the find the particular solution. So they only want one answer. And we'll do some problems, probably not today because we're out of time, but we'll do some problems where it's like, okay, I got a plus or a minus because I put the square root in. X squared equals 25. Okay, well, X is either positive 5 or negative 5. You need to go back to the initial condition and see which one fits that condition. Yeah.
Like for this step, let me go one step further and get the solution. Because if you square everything of this, you get ln x times ln x plus ln x times c plus c times ln x plus c squared, which is just a bunch of c. And then you get ln x fourth plus c. Plug it in.
Right, so, and the C ends up being this.
Yeah.
Any questions? Okay, I think that was all we had. Yeah. This was a response to some people having issues with stuff. For just strategies, not asking you to do them, but strategies. The first one, is there, like, to me, it's screaming a first step. Alex? Yeah, divide and conquer. Reduce, break it into 3 pieces and reduce. And then it's just integrating e to the stuff. It might be positive stuff, might be negative stuff, but it's e to the stuff. This one, how do we do that? Distribute, like doing products, choosing this is the U or the outside thing is the U. I don't know. Doesn't work. However, can you integrate that? Yeah. Power rule. Raise the power divided by the power. Woo. 3, suggestion, strategy.
Oh wait, it's the secant again.
It's the secant thing again. It's the secant thing again. So what's your U value? Tangent. And what's the derivative of tangent? Secant squared. Okay. Yes. Yes, thank you. Homework is day 63 in the textbook.